When we talk about the development of jet engines in the 21st century, it's incredible how far we've come. I remember the early days of this century when jet engines were powerful, but the focus was on making them more efficient and environmentally friendly.
Absolutely. The 21st century has seen some remarkable advancements in jet engine technology. Back in the early 2000s, the emphasis was primarily on fuel efficiency and reducing emissions. Airlines were pushing for engines that could deliver more power while burning less fuel because fuel costs were a significant concern. And let's not forget the increasing awareness of environmental impacts. The aviation industry had to start addressing its carbon footprint.
Exactly. One of the biggest breakthroughs was the development of high-bypass turbofan engines. These engines were designed to improve efficiency by increasing the bypass ratio, which means more air is pushed around the engine rather than through the combustion chamber. This not only improved fuel efficiency, but also reduced noise, which was another growing concern, especially for airports located near residential areas.
And that's where advancements in materials science played a crucial role. The development of new, lighter, and stronger materials like advanced composites and ceramics allowed engineers to design engines that could operate at higher temperatures without increasing weight. This was important because higher operating temperatures generally translate into better efficiency and more power output.
Right. Materials like ceramic matrix composites really pushed the boundaries. They could withstand higher temperatures than traditional metal alloys, allowing for more aggressive engine designs. The General Electric E9X, for example, which powers the Boeing 777X, uses ceramic matrix composites extensively in its turbine blades and other hot section components. This engine is one of the most efficient in the world thanks to these advancements.
The G9X is a great example of how far we've come. Another key development in the 21st century has been the integration of digital technologies into jet engine design and operation. Digital twin technology, for instance, has revolutionized how we design, test, and maintain engines. By creating a digital replica of an engine, engineers can simulate its performance under various conditions, predict potential issues before they occur, and optimize maintenance schedules to avoid unnecessary downtime.
The use of digital twins has been a game changer. It allows for real-time monitoring of engines in service, providing data that can be used to predict when parts will wear out or when performance might degrade. This predictive maintenance approach has improved reliability and reduced costs for airlines. The ability to simulate different scenarios also means that new engine designs can be tested virtually before any physical prototypes are built, saving both time and money.
And speaking of digital advancements, we can't overlook the role of additive manufacturing or 3D printing in jet engine development. In the past decade, 3D printing has allowed for the production of complex engine components that would have been impossible or extremely costly to manufacture using traditional methods. This technology has enabled the creation of lighter, stronger parts with intricate internal geometries that improve cooling and performance.
Exactly. 3D printing has opened up new possibilities for design and innovation. One of the most notable examples is the LEAP engine, developed by CFM International. The LEAP engine uses 3D printed fuel nozzles, which are not only lighter but also more efficient in terms of fuel distribution within the combustion chamber. This leads to better combustion, lower emissions, and improved fuel efficiency.
The LEAP engine is a marvel of modern engineering, but it's not just about efficiency and power anymore. There's also a growing focus on sustainability in jet engine development. With the aviation industry under increasing pressure to reduce its environmental impact, there's been a significant push towards alternative fuels, such as biofuels and synthetic fuels. Jet engines today are being designed or modified to run on these cleaner fuels without compromising performance.
That's true. Sustainable aviation fuel, or SAF, is seen as a key part of the industry's strategy to reduce carbon emissions. These fuels are derived from renewable resources and can significantly lower the carbon footprint of flights. While SAF is still more expensive than traditional jet fuel, advancements in jet engine technology are making it possible to use these fuels more efficiently, which helps offset some of the cost.
The adoption of SAF is a critical step forward, but there's also been research into more radical solutions, such as hybrid electric and fully electric propulsion systems. Although fully electric commercial jets are still a long way off, hybrid electric systems that combine traditional jet engines with electric motors are already in development. These systems aim to reduce fuel consumption and emissions further, especially during phases of flight like takeoff and landing, where fuel burn is highest.
Hybrid electric propulsion is definitely an exciting area of research. Companies like Rolls-Royce and Airbus are investing heavily in developing these technologies. The idea is to use electric power to supplement traditional jet engines, which could significantly cut fuel use and emissions on shorter flights. However, there are still many challenges to overcome, particularly related to battery technology and weight.
Battery technology is indeed one of the biggest hurdles. The energy density of current batteries is still far below that of jet fuel, which limits the range and capacity of electric aircraft. But progress is being made, and as battery technology improves, we could see more hybrid or even fully electric aircraft becoming viable in the next few decades.
It's fascinating to think about where jet engine technology is heading. From the advances we've seen in material science, digital technologies, and sustainability efforts, it's clear that the future of aviation is going to be quite different from what we've known in the past. Jet engines are becoming more efficient, cleaner, and smarter, which will help the aviation industry meet the challenges of the 21st century.
The journey of jet engine development has been one of continuous innovation, driven by the need to balance performance, efficiency, and environmental impact. The 21st century has seen some of the most significant advancements in the history of aviation, and it's likely that the pace of innovation will only accelerate as new technologies and materials are developed.
Absolutely. As engineers, we're fortunate to be part of this exciting era of change. The challenges are immense, but so are the opportunities. The work being done today will shape the future of air travel for generations to come.
And it's not just about incremental improvements, we're on the cusp of a potential revolution in how aircraft are powered and operated. Whether it's through hybrid electric propulsion, sustainable fuels, or even new propulsion concepts that we haven't fully explored yet, the 21st century is likely to be remembered as a transformative period in the history of jet engines.
I couldn't agree more. The collaboration between different disciplines, from materials science to digital technology, is driving this innovation forward. It's a reminder that solving complex challenges requires not just technical expertise, but also creativity and a willingness to explore new ideas.
And let's not forget the importance of regulatory support and industry collaboration. As we develop these new technologies, it's crucial that we have the right frameworks in place to ensure safety, reliability, and environmental stewardship. The role of international bodies like the International Civil Aviation Organization will be key in guiding these efforts.
Safety and regulation have always been at the heart of aviation, and that won't change. But as we push the boundaries of what's possible, we'll need to be even more diligent in ensuring that new technologies meet the highest standards. The future of jet engine development is bright, but it's also full of challenges that we must tackle head-on.
The road ahead is challenging, but the potential rewards are immense. The innovations we develop today will not only transform aviation, but could also have broader impacts on other industries, from energy to transportation. It's an exciting time to be involved in this field.
It certainly is. As we continue to push the envelope, it's important to remember the lessons of the past while embracing the possibilities of the future. Jet engines have come a long way since their inception, and the advancements we're seeing today are a testament to the power of human ingenuity and perseverance.
Agreed. The 21st century is shaping up to be a defining era for jet engine development, and I'm excited to see where the next few decades take us. Whether it's achieving new levels of efficiency, reducing our environmental footprint, or exploring entirely new forms of propulsion, the journey is just beginning.
And we'll be there every step of the way, contributing to the innovations that will power the future of flight. Here's to the continued evolution of jet engine technology and the incredible possibilities that lie ahead.